Okay, hello everybody. My name is Petri Tuominen. I bring you greetings from Finland, and I will be speaking English because my Serbian is very, very rusty. I'm here to tell very briefly about the topic optimizing heating networks with smart valve solutions. I'm coming from a company called VEXVE. We are a producer of valves specifically designed for heating and cooling application, meaning these district heating networks which are pre-insulated and underground. We are producing these valves for the last 40 years in our 3 factories in Finland, and we are working under brands VEXVE, Naval and Hydrox. And everything we are doing in Finland. Just as a short introduction to our company, our 3 primary markets for our valves is including energy production, meaning the power plants, district energy networks, and then also in Scandinavia we are specializing in the building networks. We are producing, for example, balancing valves for these applications. Most typical products, we are making steel and stainless steel ball valves, as well as butterfly valves up to DN1400. Then specifically for this network application, we are producing also underground valves for insulators. And today we were invited here by our Serbian partner company Izolir, who has been insulating our valves for Serbian market for more than 10 years. Topic of what I wanted to share with you a little bit is hydraulic operation of valves. Typically in a district heating network, when there is wanted some form of automation of the valves, we are using typically these valves to isolate certain parts of the network in case there is a problem. Typically, to make automation, you are needing to use some electric actuator in this kind of a bunker, or using manual so-called long stem valves operated with a T-key. And definitely these manual operating methods are best when it's convenient to go to the valve itself. However, in locations such as this one, that you are having valve chamber in middle of busy street or otherwise difficult to access location, some form of automation would be preferable. What we have been promoting for several years now is hydraulic operation of valves. We are producing ourselves this kind of hydraulic actuators that we are calling Hydrox. And the principle of hydraulic actuator on a district heating valve is, okay, on the valve we have a hydraulic actuator, hydraulic control block. In case there is anything wrong with these hydraulic hoses, it will stop immediately the flow of hydraulic oil from inside the actuator, thus keeping, for example, butterfly valve in same position. We can have hydraulic actuator and control unit even 100 meters away from each other. So we can have a valve 3 meters underground and then have this control cabinet in a convenient location, for example in some basement of nearby building. We are having a low voltage position transmitter which is operated with powered by a battery in a control unit cabinet. And then finally we are having various types of hydraulic control units, either manually operated from the site itself or remotely from a remote control center. When we are using hydraulic actuator, additionally this gives us the possibility to take full advantage of these direct buried valves. No longer is needed to put a concrete chamber just for some electric actuator, and for this purpose we are using quite a bit this kind of plastic valve chambers. Idea is that you are putting the valve underground, putting ground level all the way up the stem of the valve, and then leaving only the gear or actuator exposed. This hydraulic actuator operating principle, let's see if I can start this video. It's very simple. We are having 2 moving parts inside actuator, which is completely maintenance free, just like these valves. And user never has to go inside this actuator. Only maintenance ever required will be changing of this hydraulic oil between 5 and 10-year intervals. Then how to control this kind of hydraulic actuators? We can use them locally, meaning that we have a hydraulic control cabinet where we can integrate manual pump, electric pump, or in most simple format, no pump at all, and we are only having a more portable pump that we are plugging in. Or what is being used quite typically in more prestigious projects is this remote operation. We can make this kind of control unit where you are having at the same time possibility to operate valve locally, but it can also be integrated as part of system where we are using, for example, electric actuators. We can use fiber optics for this connection, or we can even set up a wireless control system for the valves, meaning that you can operate from your iPhone these valves. This is just some of these examples that we are providing, for example, with Izolir, meaning valve, including all the service valves, insulation, means to operate the valve, whether it be manual gears or hydraulic actuators, and also these access chambers. This year we had one of the most prestigious projects for these hydraulic actuators in Italy. They constructed new stadium in Milan, the San Siro Stadium, where we installed 16 valves, pre-insulated, some ball valve, some butterfly valve, all with hydraulic actuators and this remote operation. So in short, hydraulic actuation, for those locations where you are having difficulty to access, you want to make a remote control underground without electricity, or otherwise you cannot access the valve. Then hydraulic actuator is best solution. Finally, I want to share a little bit about how we see the future when it comes to valves. We are producing this kind of steel valves for heating and cooling for many decades now. However, we realize that if we only continue to make these steel valves, it's going to run its course. We have to find more things around these valves to offer a full solution. And this Internet of Things is offering us some nice opportunities. Typically in district heating network, we are having already quite a bit of this intelligence. In other words, this digitalization. For example, power plants, you are getting all kinds of data. You are able to remote monitor, even have self-sustained power station where there is no person there but just computers. In pumping stations we are having a lot of remote monitoring, a lot of data coming out, and oftentimes the substations themselves. They are also being remote monitored, even remote operated. However, this network, which is huge investment and significant part of whole investment, this is typically like a black hole for many energy companies. So that's why we start to look what value we could add to this network with the valves, which are there anyways. By talking to some of the biggest energy companies all over Europe, there was 3 distinct topics that we were told what would be valuable. Somehow to improve the efficiency of networks, to improve the reliability of networks. In other words, to help with the leak detection, which at the current with these copper wires is not completely without issues. And then this maintenance support, meaning allowing for this kind of preventive maintenance with valves. What is then needed? It's needed some data collected from these valves. How we can increase the intelligence in these otherwise quite stupid networks. We need underground operation, we need wireless operation, and we need some way to get power for this kind of system. And it also has to be retrofit possible. If we only start to make network smart by adding new valves, it will take forever to have a smart network. That's why there has to be also a retrofit solution. What this means in practice, we have started to integrate sensors into our valves. And from these sensors we are collecting various types of data, which we are then transmitting to a cloud of the to be used by the power company. It could look something like this. So we are having sensors on the surface of the valves as well as sensors on the service valves. Sensors giving us GPS location, although the valve typically doesn't move so much, but you get a point on the map where the valve is located. So temperature of the media. Okay, I will rush past. All kinds of data. This is not only story. This is ongoing project we are having in Fortum in Finland right now. And what we are going to offer next year for the market is two kinds of packages. Leak detection and chamber monitoring package, which will allow district energy companies to improve their location of leakages. We can integrate existing leak detection system and add sensors for the humidity and temperature in the chamber, for example. And then we are improving significantly this how we are locating the leakages in the system. This will be both for existing valves as well as for new valves. Another service package that we want to offer in future is called like network optimization package. By having information about the pressure and temperature in certain parts of the network, power company is able to optimize the generation of heat. Let's say that in the most distant corner of your network, you are knowing exactly at 15 minutes interval what is the temperature. This will allow using the power plant in effective way. When there is, for example, expected -20-degree drop in temperature, power company can start to gradually load the network instead of starting to make it full power once this has already happened. So these kind of packages we will offer, and this is discussion ongoing with our customers in Serbia and elsewhere. How do you see the future role of valves in the underground networks, and where we could add value for you, whether it is efficiency, reliability, or it is maintenance support? Thank you very much. Any questions?
Thank you, Mr. Tuominen.
Thank you.
I suppose that you will be present on the stand of colleagues from Izolir?
Yes, tomorrow also.
Or other colleagues from Izolir, so any question related can be answered.
Yes.
Svi koji žele da se malo više upoznaju sa ovim inovativnim rješenjem, kolegi iz Izolira.